Hi, welcome back. This is Nick Agram. In this video, I will be discussing congruent triangles, not just triangle, one triangle. The idea of congruency is a mathematical term, but it is only mean that a triangle A, B, C, if I will name this A, B, C, A, B, C, and if I will name this D, E, D, E, F. The idea here is that the triangle ABC is congruent, it is like this, to the triangle DEF. That means they are exactly the same. It is a copy of each other. There are tests. How do we know that we can see or we can use to know if these two triangles are congruent? The first test is what we call the side. That means if I have the side AB is equal to side EF and the side AC is equal to side ED and the side BC is equal to side BD, then we can say that the triangle ABC is congruent to triangle DEF. Okay, and there is another that we can use. It is called side angle side. This is the number one test. The second test is as I've said, is side angle side. How this works, how this test works. That means if I have this angle, call it angle A, and we have this angle E. So if, for example, I have side AB is equal to EF and side AC is equal to side ED, and angle A is equal to angle E, which is in between this side. So this is a side, and there is in between angle, and there is side again. And that means that they are congruent. And the third is angle side angle. So for example, I have this. I'll just bring that so that you can see it. See, this is B, angle B, and then we have angle F there, so that angle B is equal to angle F, and then we have AB the side AB is equal to side EF, and then we have angle A is equal to angle E. This one is equal to that one, and this one is equal to that one. When it is like that, when you find angle, two angles that are equal in those triangles, and then the side that is in between those two angles, then you have a congruent triangle. Very similar to number 3 is number 4. It is called angle, side. This side is what we call non-including side. That means if I have angle A is equal to angle E, and angle B is equal to angle F, and then we can find a side that is not included. That means it's not included it's not in between. For example, side BC is equal to FD, as we have declared here in number 1. BC is equal to FD, which is not in between of these angles that we have just discussed. Then these two triangles are also congruent. Number 5 test is will only apply when we have a right triangle. So I am going to declare that this is a right triangle. What we can find is that we have the hypotenuse leg or side. So if you can find two triangles with two right triangles with the same hypotenuse, and you can find a side that both triangles have the same length, and you have a congruent triangle. So for example, I have another triangle here. And then I will say this is A, B, C, and then we have D, E, F, and this is a right triangle. If I can say that this is equal, these hypotenuses are equal, and these sides are equal, then I can say that these two triangles are congruent triangles. They are not similar, but they are exactly a copy of each other. Why am I discussing this? Yeah, you will use congruency, the idea of congruency, when you're dealing with circles later in chapter 4 or in grade 9 if you have a grade 10 if you're in grade 9 now. So I hope you learned something, and see you next time.